Hi guys, it's me again. I'm back. When we left off, we were in the midst of filling in information for horizontal and vertical components for this projectile motion problem. There's one minor mistake that I made that I would like to point out. This is actually very important. Without this mistake, I think we'd be able to solve the problem. So this right here, 93.281. This is the initial vertical velocity. We can this vertical velocity right here is the same as this right here. The vertical velocity here. So in our vertical components, we listed the acceleration as 9.8 meters per second positive. That's very important. Since we established that any motion downwards is positive, we have to list any motion that's upwards as negative. Now we can see up here that the initial motion of the projectile, the initial vertical motion of the projectile is upwards. That's why right here, this 93.281, this one does not look like a 1, is negative. And let me circle the negative sign. Negative 93.281. Let me make that clear. That is a negative sign. There you go. Hope that makes it more clear. So, one thing I might have made it a little bit confusing by putting the horizontal and vertical components next to each other. It turns out we don't have to put any more stuff down. We can figure out the time without using horizontal. I'm going to erase that for now. We're going to bring that back in later videos when we solve for other parts of this this problem here. So I'm going to erase it for now. And I'm going to use this space to tell you what 3 projectile motion physics equations. Now if you know the 3 projectile physics equations, you can feel free to stop this video and see if you can figure out which equation we could use to solve for t, knowing a, v naught, x naught, and x. So I hope you've done that. We're back. And the 3 equations that are used most often in projectile motion are x equals x naught plus v naught t plus 1/2 at squared. Also, we have v squared equals v naught squared plus 2a x minus x naught. And lastly, we have a equals v naught plus at. No, I think that would be x equals v naught plus, it's not a t, equals v naught plus, no, sorry, that's v. Okay, so which one of these equations, let's see, let's try it for the first one. So for the first one, x naught, we plug these 2 in, we know what they are. For v naught, we have something. So we're looking for the equation in which we don't know one of the variables, but all the other ones we know, so we can solve for the one we don't know. Specifically, we're looking for one where we're solving for t. So in the first one, we know x naught, v naught, we don't know t, we know a, 9.8, and we don't know t again. So this is perfect, because we know everything except for t. So plugging in what we have for t, I can erase these 2 because we don't need them. We might need them for later equations. We don't know yet. So let's see what we have and see what we know. So for x, we have 145 meters. And since everything is in SI units, I'm not going to put units on. You'll know that's 145 meters. 145 equals 0 plus v naught times t. This would be minus because it's a negative. So 0 minus 93.281 t plus, put here, plus 1/2 times at squared. So 1/2 times 9.8 is 4.9 t squared. Let me make this clear. This is 93.281 t. Okay, and thankfully we're not going to have to go through that. Solving for t, if you look at this, you'll have to rearrange the 0 and 145 to make this a quadratic equation. I already did that for you, and I can tell you that t is 20.482 seconds. So we did it. Instead of a question mark, we can be very sure of ourselves now and put 20, sorry about that, 20.482 seconds. So I hope that was understandable. Hope you understand what we went through. We used this physics equation. We listed all our variables, all our knowns, all our unknowns, and that helped guide us toward using the equation that was most helpful in solving the problem.